There's a lot of energy around what can AI do to help us accelerate both the pace of science, but also to increase the complexity of problems we can tackle. The idea was to challenge our scientific community to bring their hardest, most interesting problems to the table and spend a day to explore what some of the best AI tools are capable of in the context of scientific problems, and to understand a bit better what are the key directions that by collaborating can we really advance the frontiers of AI to accelerate the rate at which we can work on problems. Doing that in a way that reduces the amount of time from when we have an idea to when we can do an experiment in the lab and actually build a prototype. You can use the current models to do math derivations, right? To do mathematical physics. That could result in then producing a code, right? That then runs on our supercomputers. It also could result in using the model to help brainstorm on hypotheses that you then want to test in the lab. But also the actual process of coming up with candidate designs, right? So whether it's a material or whether it's a chemical for a drug or something like that, models are now good enough that you can describe the properties you're looking for. You can describe some examples from literature, from databases, and the models can learn from those examples to try to produce new examples that meet your criteria. And I think that's one of the types of problems that people are exploring, is coming up with novel hypotheses and trying to help the model understand what humans think is novel. Human taste in problems matters a lot. Questions matter a lot. In fact, it's often the case that the questions are more important than the answers. And one of the things that we want to make progress on is how can AI help us ask better questions? We're bringing the leading edge AI technologies and with leading edge scientific instruments that are in many cases unique worldwide instruments, like the Advanced Photon Source here that's got upgraded to the world's brightest X-ray source and produces 1,000 times more data per detector than we had before. It's so fast that there's no way to actually manage experiments manually. With humans, you've got to wrap it with AI to make decisions and to have the next thing ready to go in order to get all the efficiency out of it. And it's a really creative space, right? Because these tools are so powerful now that in a weekend, I mean, you can write thousands of lines of code that advance your idea. On Friday night, you come home and you have this new idea. By Sunday, right? You've got a prototype implementation that you can try out the next day. And of course, AI is not going to solve everything. We still have to work out what's the most important things to go after. The real challenge is how can we use AI to lift billions of people out of poverty on the planet, right? I mean, that's the grand goal here. We want the U.S. to lead in science and in energy and national security and so on. But the purpose, right, is to make life better for everybody. I think science is at the heart of figuring out how to do that. But the road is going to be long in how we actually make that lift happen. And so there's a long-term agenda here, in addition to getting having lots of fun in science for the next few years.